Welcome to another video on the C programming video series for the beginners. In this video, we will talk about float, double, and long double. In C programming language, in order to represent the numbers with the decimal digits, we have seen that we have two data types available. One is float and the second one is double. Now here, if I create a variable of type float, let me call it as f here, then generally 4 bytes of memory is used for this variable of type float, and it will have the precision of 6 to 7 decimal digits. So here I can accurately store a number with 6 to 7 decimal digits. For example, in this variable, I will store the value of pi with 6 decimal digits. Now this variable can accurately store this value. Now we know that depending on the number of bytes allocated to store a particular type of value, there will be a range of values which can store in that variable. If we have to work with a value which is beyond the range of this floating point type, or if we need more number of decimal digit precision, then we have the double type. And here I will create a variable of type double, and I will call this variable as d. And in this variable, we can accurately store a value with around 15 to 16 decimal digits. For example, here I'm storing the value of pi with up to 15 decimal digits. Now, when we have to work with a value which is beyond the range of this floating point range, or if we need more precision, then we can use the variable of type double. Now for the variable of type double, around 8 bytes of memory is used, and that's why it offers more precision and better range compared to floating point type. Now what if we have to work with a value which is beyond the range of double? At that time, what we can do is we can use the size modifier long, and we can have long double type. So it will be long double, and for a variable of type long double, 16 bytes of memory is used. Again, depending on the compiler and the systems, generally 16 bytes is used, and it will offer better precision than double, and also it will offer more range of values than double. For example, here I will call this variable as ld, and I will store the pi value with up to around 18 decimal digits. Now the long double can offer better precision than double, up to around 18 to 19 decimal digits precision. Now in your program, if you are concerned about the memory and you do not need more precision and you have to work with smaller numbers, then you can go with the float. If you need better precision, or if your value is beyond the range of float, then you can use double. If you have to work with a value which is beyond the range of double, or if you need more precision than double, then you can go with the long double. So again, for float type, around 4 bytes of memory is used, and for double type, 8 bytes of memory is used, and for the long double, around 16 bytes of memory is used. Now here, this number of bytes for long double will depend on the compiler and the system. Now from the previous tutorials, if you remember, this long is the size modifier which we are using here with the data type double. Now the next thing is how these numbers with decimal places are interpreted by the C programming language. Now if I take the cursor on any of these values, you can see it says double. So by default, when we have the numbers with decimal places, the C programming language interprets them as of type double. Now as a programmer, if you want these numbers with decimal places to be interpreted as float or long double, then you have to use this suffix and you have to mention that. For example, the value that we are storing in this float variable is interpreted as double, as you guys can see here. Now if I want it to be interpreted as of type float, then I have to use the letter F. It can be uppercase or lowercase, and I have to use it as a suffix. Now, once I suffix this letter F here, if I take the cursor, now you guys can see it is interpreted as of type float. So by default, the numbers with decimal places will be interpreted as double. For example, here the value that we are storing in this double variable D, it is interpreted as double. So I don't have to use any suffix if I want the values to be interpreted as double. Now here for this variable of type long double, again the value that I have specified here, it is interpreted as double. Now I want it to be interpreted as long double. In order to do that, we have to use the suffix, and here we have to use the letter L. It can be uppercase or lowercase. Now if I take the cursor, as you guys can see, this value is interpreted, or this numeric literal is interpreted as long double. Now the next thing is, with the integer types we can have signed and unsigned, but with float, double and long double we don't have unsigned, and that's why we can't use unsigned keyword with them. The next thing that we see here is, we will use the size of operator and we will display the number of bytes used for float, double and long double. So I will use the printf function, and here I will say float and then %zu and then bytes. Then I will insert a new line. Here I will use size of, and here I will use the data type float. Similarly, I will do this for double and long double. Now I will save this program and I will run this. As we can see, for float 4 bytes of memory is used, for double 8 bytes is used, and for long double 16 bytes are used. So this value can change depending on the compiler and the system. Now the last thing that we see here is how we can display the values that are stored in these types of variables. So here I will use the printf function, and here I will say f, the variable name, and I will mention it is of type float. And in order to display the value of type float, we can use the format specifier %f, and then I will insert a new line, and then here I will refer the variable f, and then similarly I will display the value of this variable d, which is of type double. And in order to display the value of the variable of type double, we have to use the format specifier %lf. Remember, here this L is lowercase. Now here I will refer the variable as d. Similarly, for long double, I will mention the variable name ld, and here I will say long double. And for the values of type long double, we have to use the format specifier %L and then f. Now here for the values of type double, we use the format specifier %l and f. For the values of type long double, we use the format specifier %L and f. Now here I will refer the variable ld. Now if I save this program and if I run this, here we can see the values displayed. Now if I want these values to be displayed with more number of decimal places, then we can specify that. Now to display the value of type float with more number of decimal places, we will use dot, and then we have to mention how many decimal places. Here I will say 6 decimal places for this float type value, and then for this double I will use 15, so it will be .15, and then for the long double I will mention 18 decimal places. Now if I save this program and if I run this, now we can see here these values are displayed with the number of decimal places that we have mentioned. So this is it guys for this particular video. Thank you for watching. If you like the video, hit the like button. If you don't like it, hit the dislike button. If you have anything to say, write that in the comment box. For more tutorials, subscribe to the channel.